Welcome back, everyone, to the National Research Platform's Fall Training Series. In this session, we'll be showing you how to deploy your own Jupyter Hub and to deploy your own coder in your namespace. So just a quick brief overview of our training sessions so far. We started on September 2nd. Of course, all the sessions are recorded and posted online. nrp.ai/training. This is your link for training. I'm going to send it in chat. So nrp.ai is NRP's website. The training webpage has all the information you need about training, whether you want to access the slides, whether you want to access the code, try to reproduce it, and so on. And we keep it up to date with all the sessions that we're adding. So on September 9th, we showed you how to use JupyterHub. And of course, NRP manages two JupyterHub instances that all cluster users are more than welcome to use. On the backside, we are the admins of those namespaces of those JupyterHub instances. They run in their own namespaces. We're the admins of them, which means you get to use them as a user. But in this session, we'll get to show you how to set them up as an admin. So you have your own instances at your own, either if you have a domain name or an NRP subdomain, and how to admin those JupyterHub instances, how to customize them in whatever workflow requirements that you need. And next week, September 30th, is our last week of training. We're going to be having two, let me call them advanced use case training sessions. One is called Advanced 1 and Advanced 2. And we're going to be going over more advanced use cases and using the cluster. Most importantly, using GitLab, because NRP hosts its own GitLab community instance, and that GitLab is open to all cluster users. And in our GitLab, you can run CI/CD pipelines. So you can run DevOps pipelines that build Docker images within NRP. This is the reason I bring this up, because it's tied with what we're trying to do here. Because in spinning up your own JupyterHub instances, your own coder instances, you might want to run your own Docker images that have whatever tools, packages, libraries, not data. Data we have persistent storage for and makes the images relatively very heavy to load. But whatever libraries, software you're trying to load, instead of reinstalling it and redoing the process every single time because the containers are of an ephemeral fashion, you can bake them into the Docker container that you're loading from the Docker image and host them on our GitLab. And that's what we're going to be showing you next week. Among other advanced use cases like virtualization and running VMs, not necessarily containers. Of course, two sessions back to back, those are for the advanced use cases. Those are to be better fit for whatever the cluster users need. We're always more than happy to hear your suggestions regarding what you want to have us discuss in those two sessions. But for now, this is just the 1 hour session. Of course, we're more than happy to extend Q&A however long is needed, but it's just the 1 hour session. We'll be showing you minimal examples of how to start your own Jupyter Hub in your own namespaces. And just a quick important notice is that as of today, as of time of making this documentation, in this training session, it's up to date. Whatever we're showing you today works. It's works in how the cluster is set up, how Kubernetes is set up in our current versions of the cluster software, Kubernetes, Jupyter Hub. But your number one source of truth should always be NRP's documentation, which you can access at nrp.ai/documentation. I just sent it in chat for everyone. So that's your own number one source of information. The training sessions, whether live or recording, are just to supplement that and showing you a live example. And to be able to follow along, first thing you need is the repository link where we keep all the code examples. And I'm going to send it in chat. It's on GitHub. You don't even have to clone the repositories. You can just follow along. Let me show you very briefly in my browser window. So this is our session here today, deploying JupyterHub and Coder. And really the only things you care about are those YAML files. So the JupyterHub config YAML files and the three examples that we have. Sorry, not this one. Those are the ones you need to have on hand, so you don't have to copy them. Everything else we're going to be going through it iteratively and interactively. The other thing is NRP's own docs for deploying JupyterHub. So the tutorial itself is heavily based on the documentation that we provide you, and virtually you can use the documentation without having to use the training session today, but this is more of an interactive space. I just sent you the link in chat for our documentation. And lastly, we show you how to deploy JupyterHub as a minimal example, but JupyterHub itself on Kubernetes is something that offers plenty of features that can be extended. You can make a very elaborate JupyterHub deployments, and it's always very worth the to check out JupyterHub's own documentation. There's a guide that is called Zero to JupyterHub with Kubernetes, and it shows you every single thing that you might need to have additional use cases. So, for example, you might want to have a very specific use case using JupyterHub. This guide shows you exactly how to do it. And let's get started. So this is the end of my slideshow. It's just simple slides because the rest of it is interactive. Let me show you here. So hope everyone can see my browser. If not, please let me know. So this is our training repository. Please make sure you get the YAML files from here. What we're going to be doing is that we're going to be going over the steps into deploying our own Jupyter. So this is our documentation, nrp.ai/documentation, which is in chat if you need it. See on the left pane here, you have Jupyter and Jupyter Service. This explains the features of NRP's JupyterHub. So I'm hoping everyone on this call can access this JupyterHub instance and you can use it as users. You can see one of the features is that it attaches a 5 GB persistent volume for each user at their home directory. And as you most likely already know, if you want to extend beyond the 5 GB, this is where you ask us and we can do it manually. As you can see, the storage is created in the West Ceph pool. That's where the storage is, from which storage pool it's being provisioned. You can ask admins to move it to a different region. And the reason I bring this up is to show you the differences in deploying your own. And the second guide here shows you how to run your own Jupyter pod. So a single pod, not a whole instance, not an instance for users, just a single pod in your namespace that runs Jupyter. But what we're going to be doing here today is deploying our own Jupyter Hub. So you can see the initial steps here, and if you want to deploy your own JupyterHub, so you can see NRP's one is jupyterhub-west.nrp-nautilus.io. But let's say, for the sake of argument, you're spinning up a classroom and you want it to be, let's say, for example, CS1122 at, let's say, campus x.nrp-nautilus.io. And this is what your URL is going to look like. Your users are going to be authenticating through this link. They'll be accessing JupyterHub through the interface. So first step for you is to pick what that URL is going to look like, what that subdomain is. So it's going to be something.nrp-nautilus.io. The first step here is that to have a descriptive name, because odds are if you go for, let's say, JupyterHub East, judging by West, you can assume there's East, it's already taken. You need to have a unique URL name. So if it's descriptive, then there won't be any conflict. So if it's a course name, a lab name, nothing that is generic like JupyterHub or Kubernetes JupyterHub is perfect. And once you have that name picked out, the next step for you is to have a CI logon application. So to show you, this is when you access it as logged out. And actually, let me show you in a private window. I visited from here. I sign in. And for NRP's JupyterHub takes you to CI logon. So the first step in having your JupyterHub work is to have your CI logon work. And you need to have a registered CI logon application with CI logon. And CI logon is a third party. It's its own entity. It's not managed by NRP. It's not, there's no NRP middleman between you and CI logon. When you're starting your own JupyterHub instance with CI logon, you have to create your own CI logon application that does authentication like we're doing right now. So the steps to do that are very simple. First thing you have to do is to log in to visit this link. So it's cilogon.org /OAuth2 /register. So link to sign up for a CI logon application. And of course, you're gonna name it. So you're gonna follow the steps here. So the client name, what are you gonna call the client? Let's say, of course, don't, if you're planning on deploying it, ideally won't be called like JupyterHub example or something, but I'm just filling this out just to show you how to fill it out. So JupyterHub example, or I can call it CS XYZ University of XYZ. And contact email, this is very important. This is the email that will receive confirmation once it's logged in and other details and correspondence. So you'd fill out your own email. Home URL. Now, this is not arbitrary. This is the exact URL of the application, what it's going to use. So it's going to be, if you have your own domain name, we show you the steps on how to run things using your own domain name on NRP. But if you're using NRP for your subdomain, it's going to be whatever you want to run JupyterHub at. So it's going to be, for example, CSXYZ University of XYZ .nrp-nautilus.io. And this is a literal step. Please make sure you don't make any typos in this one. And then callback URLs, you're going to copy over this one and you're going to follow the template here. So you can see it's /hub/OAuth underscore callback. So also please make sure this is not, there's no typos in this one. Of course, you're going to make it confidential. You're going to add these scopes and you're going to follow the steps one by one. So you can see client confidential. This maps out here. Scopes, you're adding these scopes. You're going to select them. Refresh token, no. And then you're going to register a client. And now I'm not going to register a client just so I don't, create more work for the CI logon folks, just for an example. But if you're following along at your own pace and you want to sign up, register your own CI logon application, please fill out the details and send them, and we're here to help you through the process. Now, once you hit register client, you're sending it to the CI logon folks. Once they process it, you'll receive an email saying your application has been registered. What this means is that you can use CI logon, which allows you to use your campus single sign-on, use identity providers, which you can customize for your JupyterHub instance. But for the sake of this tutorial, we're gonna be skipping the step with CI logon just so we don't go through the manual process of signing up for an application and waiting for a response back. We're going to be using password authentication, which let me tell you, it's not secure and your instance will be flagged as insecure and we'll tell you to fix it. So please, just for the sake of this tutorial, we're going to be using, let me call it a dummy authenticator that uses a password login, but please just use that for tutorial purposes. As soon as you're done, please shut down that JupyterHub instance. We'll show you how and use CI logon instead. So next step is you need to have your JupyterHub run within your namespace. Now, ideally, you would run JupyterHub in its own isolated namespace. Like, we don't ask you for a limit on namespace numbers. Feel free to create an individual namespace for every JupyterHub instance that you start. And of course, the steps here are what we went through in previous sessions. You can see here once you visit the link, you can see your own namespaces here. You can create the namespace and you can run JupyterHub inside of it. If you don't know how to create your own namespace, please let us know and we can point you to the right place. But you need to have your own namespace that you're following this tutorial in, that you're running JupyterHub in. And now the next step is, and you can see here, we give you a guide for step by step. But the next thing here is use this template. I'm just going to show you this template. So if you click on it to open it, you can see here. Let's wait for it to load and Let's give it some time. For some reason it's not happening. Oh, here we go. Okay, so just to show you this template, because we're going to be following a similar one today. So the very important sections here is that, let me zoom in. So this is the YAML file that you're going to be using. We're going to be showing you step by step. But just the parts that are different in this one from the one we're going to be using. So this one shows config CI logon authenticator. Now CI logon, once they email you saying we approved your application, they're going to send you two pieces of very important information. One of them being the client ID and the client secret. And of course, those are for you to keep safe, but not share with anyone outside of your namespace adminship. And you need to add them to your YAML. So this template, there's a copy button. You can copy it here. You can paste it locally when you're trying to deploy JupyterHub and paste in your own unique client ID and secret and change this line here to be unique as well to what you used with the application. So this needs to match what you sent into say logon. So when we said CS XYZ of University XYZ, admin users, whoever you add here through email, when you add them, they have admin control over your instance. And of course, you can always modify the list. It's not set in stone. And you can see JupyterHub access, admin access true. This is the add JupyterHub admin list again, and authenticator class is CI logon. So this line here, very important. This tells my instance you're using CI logon for authentication, not password, not any other sort of authentication. And there's different ways for authentication. Password is not secure, but there are different ways for using let me call it third party or authentication clients like CI logon. You can use customized OAuth applications. Of course, CI logon is the easiest to use. That's what we tell you to use. And of course, allowed IDPs. And this is a very important step. So allowed IDPs, this is where you get to your own first customization that you get to do that gives you an advantage over running our own public one. So IDP lookup, we give you this link. I'm going to copy it and show it to you. And allowed IDPs is where you specify the IDPs you want to include. So let me paste this and show you what it looks like. So this is a list of all the institutions on Sailog. So that's why it looks like a wall of text. If we pretty print it in our browser, you can see, let's say I want to add UCSD. I searched for UCSD and here we go. You can see entity ID, this entire URN ID, and you can see here, allowed IDPs. This is where I put the URN. So if I'm adding UCSD, this would replace this. And allowed domains would be all the domains that the UCSD email has. So like for example, ucsd.edu is one. Some campuses have their students on a subdomain, like mascotname.campusname.edu or whatever subdomain it uses for students. So sometimes students have a different subdomain. So please always make sure to include that as well. So for example, this is arbitrary, not true, just hypothetical. You can say ucsd.edu and student.ucsd.edu, for example. And username derivation, we always use username claim email. And of course, you can add a list. So this is one. You can also add another one, another one, another one. And by that, you're including explicitly what institutes your users are allowed to use. So when you add UCSD, for example, of course, sorry, I lost the page. Here we go. So if you include UCSD, for example, and You launch your Jupyter Hub. It's gonna look like this. Once you try to sign in, it's gonna and takes you to CI log on. It's only gonna list the institutes that you added. So if you only add UCSD, then it'll only show one option like this. And that is the first control of who gets to access and who doesn't that you can add, of course. All of this, you can copy it all the same. You can see here, so you can see this is for the hub configuration. You can see here the database it's going to be using. If it's okay if you don't understand what this stuff is, I'm just showing you what the differences are that you can change. So one gigabyte is more than plenty. You don't need to change this. This is what is used on the backend for Jupyter Hub to work. So it's not more storage if you increase it. And rook-ceph-block, this means it's from the Western region. And since it's used as a database, it's only accessed by one pod at a time. So we use block storage, so RBD storage. Of course, if you don't know the differences in storage classes on NRP, let me show you the link. So this is the difference between different storage classes on NRP. And this is starting our database in the West region. And you can see our hub pod. So Jupyter starts a pod we call a hub pod. You can see we're setting the requests as 100 M. This means 1/10 of a CPU core. And we're setting the memory as 512 megabytes. These are the minimum it requests, so it's hogging them at all times. And the limits, 2 CPU cores, 1 GB of memory. This is more than plenty. This is what's running in the backend. So no need to worry about that. Now, the other thing is secret token. This needs to be a random token that the proxy pod uses. Now, the proxy pod is just a communication proxy between the hub and everything else, and it needs to have a secret token. This is not something this is arbitrary. You can set this one, but it needs to be secure. So what you do, as we showed you in our documentation, we tell you second step after registration, after having your own namespace, is to run open SSL ran-hex 32. And for us to show you here, I'm just going to show you a new terminal window. So this is my terminal window, zooming in. And if I type in this command, you can see it gave me a random token. This is just to give me a secure random token that I can use. So it's just for generation. I don't have to use this one. I can change it. As long as I put it here, I'm all good. You can see the proxy pod also has requests and limits. You can use the default. There's no need to change them. And now the last part is single user. Single user is every user's instance. So you can see virtually you don't need to change these things a lot, but you can see one thing we add is extra node affinity for region. This means your instance targets a node label based on what host it starts in. So you can see it's using topology.kubernetes.io/region in US-west. The reason we show you this template that starts pods by default, tries to put them all, or not tries, enforces since it's required, not preferred. That means it's enforced. It starts them in the West region, which is mainly the West Coast. The reason we do so is because you can see under storage, this is also one section we care about. The storage class we're using. Of course, this is similar to how we provision pods. For each user's instance that starts, it has a persistent storage, persistent volume claim, just like how we did with our own public Jupyter Hub. It's in rook-ceph-block, which is like we said, this starts in the West region. So this part right here starts my pod in the West region. And this part right here sets my storage in the West region. By doing both of them in the same region, I have my storage coming from a different server, from a storage server, storage node. And I have my pod, my actual container, also running on its own, on a server that is not the server that has the storage. It's running from a different node, a compute node or a worker node, not a node that is provisioning storage. So by having them being geographically close, I get better performance because my storage is faster, both in reads and writes and so on. And you can see this is the part that we use in our Jupyter Hub. We set the capacity by default to 5 gigabytes. You can see here it's a parameter that you can change. We don't enforce 5 gigs. This is only the default value that we set. But you can set a different one in your namespace. And lastly, image. This is the default image that the instance starts with. This is a Docker image. So this image itself, it's being pulled from a registry. You can use Docker Hub, you can use a GitHub registry, you can use our GitLab's container registries if you build your own image, customized Docker for a container, Docker image. You can pull that into your Jupyter Hub instance. Now, one main thing to note here is that there is an expectation of the Jupyter Hub images, which is of course to have JupyterHub and run it on start so the images work. So you can't just plug in whatever image you want in here. It needs to be a JupyterHub compliant image that runs Jupyter on start. So if you plug in Ubuntu, this will fail. If you plug in something that runs a Jupyter notebook, it'll work. If it's JupyterHub compliant and doesn't have any issues in how it's defined. You can see here we're specifying CPU, limit 3, guarantee 3, which means you're requesting 3 cores minimum and 3 cores tops. And of course, if you set the two numbers to be equal, you get more CPU performance out of the 3 cores. And memory also, you can see here it's arbitrary based on needs, of course, how you're setting it to 8 gigabytes and limit 8 gigabytes. Extra resources, here is where we can request more things like GPUs, like FPGAs, like whatever is a Kubernetes resource that you can request, you can add it here. And of course, the last thing I want to mention here is profile list, or before last thing. Profile list is how you add with the Kubernetes spawner, with the GUI, how to add more image options. So you can see this is our own Jupyter Hub. Or sorry, not this one. This is our own Jupyter Hub. And forget about the GUI pickers, just look at the images now, and this is how we specify them. So profile list, you can see SciPy and R, Julia, you can map out your own images, and you can see cube spawner override. This is the same language that you have to use. Display name is what it shows on the spawner for users. Image spec is what it's pulling as an actual image. So this is the part where you can, let's say, switch out our own images, add your own, or just add to the bottom. And you can see some of the images are not hosted on NRP, some of them are hosted on NRP that have more features that we developed in-house and so on. And scheduling, you don't need to mess with this for now. You can read more on scheduling from the Zero to the Jupyter Hub guide. Ingress, this is one part you also have to change. This needs to match. So your name.nrp-notice.io, it's not actually your name, it's your name for the Jupyter Hub instance, not your personal name. It's the same one that we used here, so same thing. CS XYZ, dash university XYZ, so on. One, two, three places that use the say logon URL that you gave them. And this is the last part. So call Jupyter Hub, and this is very important detail, is that Jupyter Hub has a feature called culling, which means all user instances are auto-terminated when left idle. Now, to be able to launch your own Jupyter Hub instance, this is enforced per policy. You have to add this block that enforces culling on instances that are left idle. Now, this is not an invasive or abusive process. It only terminates idle sessions. As long as the users are using them, they're kept running. There's no shutting down in the middle of your work. And after you have all of these pieces, you can deploy your own Jupyter Hub instance, and that's what we're going to be showing you. So let me show you my terminal window. Here we go. Terminal clear. Now, first thing in installing Jupyter Hub is, let me I'm just gonna create a directory and do the steps in it. And I'm gonna clone the repository. And you can see we start here. So just give you the clone command. And just to answer a question, what if I have a no hub command running? It's not about having processes in the background. So just to give you a clear distinction, it's about user interaction with the actual JupyterHub instance. So if you run processes, they will still be terminated because you as a user are not interacting with your session. That's what idle in this case means. Because if you're running something that is not interactive, uh, there are more efficient ways than running it in JupyterHub, and that's where Kubernetes comes in with batch jobs, for example, and standalone pods and deployments and whatnot. So if you run your own JupyterHub instance and you run processes in it, let's say you're training a model, you run all the scripts to train a model, you run them either in NoHub or you run them in the background or you run them in a GNU screen or anything that is not interactive or running in the background, that will not make it not terminate. It will still terminate because you as a user are not interacting with it. So instead of forcing yourself to stay awake as long as it's training and moving the mouse and opening the browser tab just to keep it alive, there are more efficient ways, and we're more than happy to show you different ways. In running your training workflows, for example. So they don't run in JupyterHub, they run in their own more efficient ways. And once I clone it, you can see, so fall training, I'm going to do 7th session and code, and I'm going to start with the basic one. And here, to be able to deploy my own JupyterHub, like we said, our first step is having our own namespace. So what I'm going to be installing it in is my own namespace. So cube control and get pods dash n training test to delete later. And I hope everyone on this call has their own JupyterHub and just their own namespace to install JupyterHub in. And please, you can see I already have an instance running, so I'm just gonna remove that to install a new one. Please ignore the steps I'm doing. I'm gonna show you what we're doing in a second. Uh, okay, that's fine. So next step here, as you probably already saw, and what I'm trying to do in uninstalling the JupyterHub instance that I already have, is that I use the command called helm. So, sorry, it's helm. So first thing is to install Helm. And to explain what Helm is, the simplest way to think of it is if you think of Kubernetes as the cloud and the cloud OS, let me call it, then Helm comes in as like a package manager. So instead of, let's say I'm running JupyterHub, it runs a persistent volume claim, starts up a database. It has multiple components and dependencies, and it starts an ingress. Instead of doing all those steps manually, that's where Helm comes in. So I have one YAML that configures everything. I run the Helm command and it installs it in my namespace, and you can sort of relate it to home, how you brew install something or apt install something. We're going to be Helm installing JupyterHub. So first thing for you is to install Helm. And I know many of you are on Linux. So for Linux and Mac, it's as simple as running those three commands, which I'm going to send in chat. And you can also for Mac, um, Mac OS. And for Windows, it gets a little slightly more complicated. If you use Chocolatey or Scoop to install kube login, So you already have the tools in place. You can use Shoko and Scoop. I'm just going to send the link on installing Helm in chat. And if you use the binary directly, you can still do the same thing in getting the binary for Helm. So you can see Helm releases. I sent you the link now. You can see the Windows, AMD64 and ARM64. So you can download this, extract the zip file, extract the zip archive, and you can see the helm.exe. You need to copy this, of course, without renaming it. It needs to be called helm.exe and copy that to the exact same directory or folder where you have kube control and kube login, which is called kube control underscore OIDC dash login. So naming on Windows matters. If you rename it, it won't work. And you can just copy the exe and place it in the same folder. And it needs to be in the same folder, not because it needs to be in the same folder, but because that folder is already in your path. So your system already looks for binaries and executables in that path. So pasting it there makes it easier for Windows to see it. And for hub and proxy, I'm just answering your question. For hub and proxy CPU memory limits, will these limits be needed to be increased for certain class size network traffic? So those limits are generally good. They're like more instances that they spawn up don't request more resources beyond these limits in all the instances that we've seen. But in general, just to show you one thing, so this is our own Grafana. So we have our Grafana dashboards, and you can see if you type in pods, you can see namespace pods, and I can type in, for example, JupyterLab-East, for example, because here's an instance that is running a proxy and a hub, and you can click on the pod itself. And you can see, so this is our proxy pod. It's running a CHP container. You can see its limits are 2, but it's using way less than even 100th of one of a CPU core. And you can see same thing for memory. You can look at the container. It's using 19 megabytes when the limit is 1 gigabyte. Same thing for Jupyter Lab. This is the Jupyter Lab is the namespace that we run our own Jupyter Hub in. And you can run you can look at the proxy pod, for example. You can see it's using a fraction of what is requested, and hub. You can also see it's using less than 20%. And I'm just going to send the Grafana link in chat. See, we have different Grafana dashboards. So we haven't seen a case where you need more than what we specify in the template, but you can always monitor in Grafana. If your instance is using more, you can request more. And once you have Helm installed, I hope everyone had a chance to install Helm. Please let me know if you're having issues. I'm monitoring the Q&A. If you have issues with installing Helm, please let me know. But once it's installed, you should be able to run Helm version. So it's brew install Helm. If you run Helm version, you should be able to see the one that you're running. And then we're ready for the next step. The next step is, so you can see here in my directory. So this is my config file, and let me show you in VS Code what my config file looks like. So I'm in my downloads training, fall training, and code and open. And you can see here, so this is, hope everyone can see my screen. This is our config file. You can see this is similar to the one that we used. You can see one thing we changed is we added the secret token that we talked about, and Another thing we changed is that we are using training-test.nrp-nautilus.io. Please use a different name because names can't collide. So if I'm using this one, I'm gonna change it so you have it free. But please use a unique name so no one trying it conflicts with one another. And I kept calling, and you can see here this is one thing we changed. So we're using authenticator class as a dummy. So this is called a dummy authenticator. As you can tell by the name, it's purely for testing. So if you try this one in deployment, it will be insecure. Please shut it down as soon as you implement it. But just to show you, admin users is just one user called admin. So we're specifying a username here. So I can call it admin123, for example, and password training123, which is completely insecure. Just gonna add a percentage sign just to show you, and we didn't change anything else really. Now from our terminal, from the directory that has the file. So you can see here we have, sorry, we're in basic. You can see here this is our YAML file, and you can see here we gave you the commands to run it. So you can get a secret token by running this command. Since we already added a token, we don't care much about doing the rest. Now, the next step is Helm repo add JupyterHub. And I'm gonna paste it in chat. I see a question in Q&A. Can others copy the chat? Please let me know if you're unable to copy the commands in chat. But this command here, oh sorry, here we go. So let me paste in terminal so I can zoom in more. So this is the command that we're adding, which is helm repo add JupyterHub from this link, which is jupyterhub.github.io/helm-chart. And you can see we already added this repo. So this adds our repo to the list of repos. Just like if you use apt on Ubuntu, for example, or Debian distros, this is how similarly you add repo sources. And Helm repo update means pull from the latest, which is similar to apt update or apt-get update. And Helm, so there's Helm install and there's Helm upgrade. I always like to run upgrade in case I'm installing an upgrade and one that exists. So upgrade, if it doesn't exist, it installs it. If it does exist, it upgrades it. The specifications we provide. And so I have my window here. Here's our command here. And here's our other terminal window. So what I'm gonna do here, K9S is a Kubernetes command line tool that we showed you before. I'm just gonna show you. So this is the namespace I'm running in. If I type in :helm, this is where you see my Helm chart. So far, nothing exists. Now I'm gonna deploy my Helm chart with Helm upgrade -- cleanup on fail -- install jhub basic. This is the name of my Helm chart. I can rename this one as long as this one is JupyterHub /JupyterHub, and then namespace. I'm defining my own namespace to tell it where to install. If you don't specify this, it'll use the default namespace that Kubernetes uses. So please make sure you have configured a default namespace if you're not explicitly specifying one. And version 3.3-7 to match our docs. If you're using the latest, things might differ a lot. So if you run into any issues with installing latest with the same configs, we're more than happy to help you with it. And values, this is very important. This is where you specify the values YAML. And the other ones are just wait and time out 10 minutes. So it times out in 10 minutes if something goes wrong and doesn't try installing forever. But of course, you can run without them. And once I hit enter, you can see release jhub-basic does not exist. Installing it now. You can see jhub basic. This is what it's calling my home chart, and it's pending install. So I'm just gonna wait on it. And you can see in my pods, my proxy pod, it's 10 seconds old and it's already running. My hub pod is 14 seconds old and it's container creating. You can see in PVC for persistent volume claims, it created a hub dash DB dash dir, so a hub directory. Sorry, a hub volume. See, it's 30 seconds old. Its capacity is 1 GB. This is a claim from an old one, so I'm just gonna delete it and run back to my pods. Both of them are running. Helm, can see 50 seconds status deployed. And in K9S, my hub pod is showing up as blue, which is healthy, happy, ready. Of course, in Kubernetes, you can also run kube control get pods dash n and training test to delete later. You can see both of them are running. And of course, you know how we can run kube control get pvc dash n and use the same namespace. You don't run kube control get helm because helm has its own command line tool, so this will not work. You just run helm list dash n and namespace name. It shows status deployed. And one thing to show you is kube control get ingress. And copy namespace name. You can see, here's my host. training-test-mfsada.nrp-nautilus.io. And now I can visit my browser and you can see, sign in. So I called it admin123 and I called it training123%. And that's it. You can see I have SciPy, I have R, Julia, TensorFlow, PyTorch, data science, and I can add my own images. Now, another thing to show you here, this YAML file, so it's simply by switching the YAML file to this one, you can look at the differences. You can see that we added in our cube spawner, we can have options for, you can see. So profile list, you can see here the things that we changed. I'm just showing you real quick, is that our cube spawner, we have CPU limit and guarantee, memory limit, and extra resources. We're requesting 0 GPUs. But in our profile list, you see we have different options. So this is another YAML file you can look at. For example, we have one called small, which is 1 CPU, 2 GB of RAM. You can see we have the image, CPU limits, CPU guarantee, memory, and it's starting in West. Same thing, let's say get down to GPU large. You can see we added extra resources limit and extra resources guarantees, and we're adding 2 GPUs just to show you what that looks like. So this is the command that we ran. I'm just going to copy it and go back to O2 and paste it. Now the only thing here is I need to match the YAML file. So this YAML file is from the local directory you're in, so I need to match its name. You can see in my O2 directory, it's called o1-jupyterhub-config. And I'm gonna paste this, and just to show you what's happening here, once it starts installing, it'll stop my old ones, start the new ones. So you can see, and it started my new ones. And container creating, we just wait on it. You can hit D on K9S for describe. It'll show you multi-attach error as soon as it starts because it's releasing the volume from the old node it was on. Let's just give it a minute. You can see while it starts, you'll see service unavailable. So I see a question, what happens when multiple people try to deploy on the same ingress? You'll get a Helm error that says that something exists at this ingress, so use a different one. And I see a question, I get this error when I ran the script. So user, let me check on this error for you. But let me just check on this. So one thing to show you here, once we ran that YAML, if we try to visit it again, and here we go. See, uh, small, medium, large, GPU small, GPU large. And just very quickly, I start at GPU large and I go back to K9S. You'll see it starts a pod based on the username. So you can see every user has their own pod that starts their instance. So it's a normally Kubernetes pod, and you can, for example, for K9S, you can hit Y for YAML. You can see all its information. So you can scroll down to requests and limits, and you can see here. So see it's requesting CPU memory translated to bytes, so it looks a little weird. And you can see it's requesting 2 GPUs. So you as an admin can always run kube control on get the kube control get pods, kube control logs of the pod in the namespace and so on, and use the Kubernetes features as a namespace admin to uh, to see the pods and see what's going on. Of course, there's no logs because the pod hasn't started yet, so we'll just wait on it a little bit. But you can run kube control get pods, my bad. And you can see the pod. Oh, you can see this is one example of what we talked about in previous sessions. If you try to get pods in a namespace that does not exist, it doesn't tell you namespace does not exist, it tells you no resources found in that namespace. So please check for typos. You can see it's still container creating, so we'll just give it its time. But I just also want to show you PVCs. You can see it created a new claim, so a new PVC for the user. And you can see age is 2 minutes and it's 5 GB. It doesn't create a new volume for the same user when they try to start a new instance. It'll start the same volume if it doesn't exist, or create a new one if they're a first time user. If it does exist, sorry. It'll use it if it exists and create a new one if it doesn't. And you can always run kube control edit. So if I run kube control, edit this PVC in my namespace, it'll open my local editor. Oh, edit PVC. Forgot to say PVC. So edit PVC name. You can see this is my local editor and 5 gigs. Now, if I want to extend the user's storage as an admin, I can modify this number. And once they start a new instance, so if they have a running instance, it won't change. They start a new instance, it will change, and it'll affect the new storage. And of course, one last thing to note here is that you don't have to add users as a Kubernetes namespace user. They access JupyterHub from its own web interface that is not tied to them being in the Kubernetes namespace. That's one thing. The other thing is adding a user as an admin in your namespace that runs JupyterHub is you giving them to the full namespace so they can get access to everything because they're namespace admin. They're at the highest level of access in the namespace. So they can exec into any of the pods running and run inside of it. So that's also one thing to be wary of. I think this is a good place to pause since the pod is taking too long to start. Looks like it's pulling the image for a while now, so we're just gonna give it its time and pause here. I'm gonna stop the recording here and go for your questions. So you can ask questions. If anybody wants to unmute, feel free to unmute and ask. Let me stop sharing and stop recording.